Welcome to Pure 1 Chapter 6. This is the last chapter of the geometry series of Chapter 4, 5, and 6. 4 is about transformation in graphs, and then Chapter 5 is about straight lines, and Chapter 6 about circles. Now, 5 and 6 has a very close relationship because straight lines does get related to circles a lot. So you will use a lot of the straight line stuff you've learned Chapter 5 to Chapter 6. Okay, right. Chapter 6, circles. First of all, before we look at circles, the 6.1 in this lesson, which is about looking into the midpoints and the perpendicular bisector. So still about straight lines, but in a different context. So we'll see. Okay, and then 6.2 about equation of circle. From there, you can see a lot of straight line circles, and then you will look at tangent, some circle theorems, and a lot of you hate circle theorems back in GCSE. But anyway, 6.5 circles and triangles. So you've got a lot more problem-solving questions here, a lot more geometry questions in there, problem solving. But anyway, let's not dive too deep. Let's take it bit by bit, just like my burger. Okay, bite by bite. 6.1. Midpoints and perpendicular bisector. The midpoint, to work with the midpoint, we add them up and halve it. So we add up the x coordinate, x1 plus x2, halve it, and then y1 plus y2, halve it. But what is the big bracket outside? Well, it's the coordinates. That's your x coordinate. To find a midpoint, you add the x coordinates, halve it, add the y coordinates, halve it. Okay. If you want to have a go in an example, be my guest, and you'll possibly have a go with them. Otherwise, I would just go for it now. So question A, to find a midpoint between that, I will do -3 plus 0, halve it, 2 plus 6, halve it. Put it in a calculator one by one, you should get -3/2 and 4. Okay. Right. Part B, the same thing, but this time just surd form. So don't fret, just do one by one. So for the x coordinate, it's √2 minus √3 plus 3√2 plus √3 over 2. And then for the y, it's 3√2 plus 4√3 minus √2 plus 2√3 over 2. Okay. So again, just put in a calculator one by one. You should get the, and then you should get, let me have a look on my answers. Just can't be asked to work it myself. You should get 2√2 for the x, and for the y, you get √2 plus 3√3. Okay, right, and that's the midpoint. Okay, right, next one. There's no practice for this one because you can do them, from textbook, from different exercise. It should be quite fairly simple. The midpoint, it's a bit small. Let me make it bigger. Find the midpoint between given the midpoint of AB is -5 and 3, and the coordinates of A is 5 minus 2. Find the coordinates of B. So reverse midpoint. So reverse midpoint. So what we can do, we can let B equal to xy. Okay, so we don't know the coordinates of B, we can let it to be xy. Then we can set up the equation using midpoint. So the midpoint of A is 5 plus x over 2, and then -2 plus y over 2 as a coordinate will equal to -5, 3. So the midpoint of AB, so add up the x coordinate of A and the y coordinates of B, A and B, halve it. So what it means is we can get two equations. 5 plus x halve it equals to -5, and then -2 plus y over 2 equals 3. Solve it one by one, you should get x equals to, so times it by 2, and then -5, so -10 minus 5 is -15. -15, and then for y equals 2 times 3 is 6, 6 plus 2 is 8. So b equals to -15, 8. Easy peasy. Yeah, midpoint easy. Right. Have a go. Oh, I said no practice question. That's a lie, because there is a practice question here. Pause the video, have a go at the questions. Okay, when you're ready for the answer, you can press play. Well, here are the answers. So, quite simple. So I'm not going to explain anymore. The only thing I would want to explain is in here. So how I did the equation, did the final answer. I just split the numerator. Okay, split the numerator, just like the chicken nuggets, split the skin and the meat. I know some people do that, but that's disgusting. So if you know what I'm talking about, some people eat the nuggets with the skin off, they peel off their skin, and then eat the meat first, and then dip the skin in the sauce, whatever. That's crazy. It's like a cat without the head. Have you seen the cat without the fur? There's a species of a cat without fur. It's called sphinx. I can't remember the name. Google itself. I think it's Sphinx. Anyway, so part C is that one. Right. Okay. Next one. Okay. We'll talk about midpoints. Next thing, perpendicular bisector. So perpendicular bisector is the straight line. Now, straight line means y minus y1 equals mx minus x1. We're still going to use this. Okay, we're still going to use this. That passes through the midpoint of highlighter, passes through the midpoint of AB and perpendicular to AB. So in here, in this case, we can see CD, okay, is we call it the perpendicular bisector of AB. Now, I use the sign. We know mathematicians are lazy, so including myself, perpendicular. So that's a right angle, and then R means perpendicular bisector of AB. It's just symbol, okay? Perpendicular bisector of AB. So what else do we know? We know M is a midpoint, right? So M is a midpoint. That means these two lines are equal in length, you know, these two part, and then so is these two part. Oh, actually, yep. Okay. What else? We know it's a right angle. What it means is the gradient of AB times the gradient of CD. MCD, what does it remind you of? McDonald's equals to -1. So what we know is the gradient of CD equals to negative reciprocal of AB. So where did the times minus 1 come from? That's the mathematical definition of two lines being perpendicular. If two lines are perpendicular, the gradient, the product of the gradients equals to -1. Means when you multiply two, gradient equals -1. So if you flip it around, that's where you get the negative reciprocal that a lot of you remember. Okay, right. So we're going to use this example. A and B as coordinates -1, 4, and 3 and -6 respectively. Find the equation of the line L, which is perpendicular bisector. Find the equation of the line L. We know equation. This is still a straight line, so we're going to use this. Okay, the y minus y1 equals mx minus x1. Tell me the two things that you need to use this formula. Yep, Dora the Explorer is waiting. Yes, you're right. The gradient and a point. Right. So to find a gradient, okay, we can use the 2 points. We can use these 2 points. We've got a point, haven't we? Do we? Now, perpendicular bisector of AB. So if you think about AB in here, okay, they might not be correct. Might not be drawing correctly. Actually, it's not, because -1, 4 should be in a higher position than 3 minus 6. So that should be like this, something like this. Okay. Anyway, it doesn't matter how we draw it. What we're trying to do is we're trying to find the perpendicular bisector, means the green line in here. We're trying to find this green line in here. That's line L. Okay. I write the L a little bit weird in maths because otherwise I get confused myself with a 1, with an I, with an L. You know how perfect my writing is. You know. Right. So to do this, what we need is, okay, the M, okay, is the negative reciprocal of the gradient AB because they're perpendicular, right? And what the point? The point is the point M, which is the midpoint of AB. Okay, so it's not, we can't use the point A and B because the line L does not pass through A nor B. We have to use the midpoint of M. Okay, right, so let's work it out. So to work out the gradient, let's work out the gradient of AB first. So the gradient of AB, so the M AB equals to y2 minus y1 over x2 minus x1, which should give you -5/2. Therefore, the gradient of L, ML, equals to 2/5, the negative reciprocal. Okay, what about the midpoint AB? So the midpoint, okay, M equals the midpoint of AB, which is -1 plus 3/2 and 4 plus -6/2. Put in the calculator separately, you get 1 and -1. So these are two ingredients that you need for your formula. Y minus y1 equals mx minus x1. So y minus y1 minus 1 equals m 2/5 of x minus x1. So y plus 1 equal, does the question need me to write in any form of the equation? No, it's any form, so make it y the subject in here. Expand the bracket, 2/5 of x minus 2/5, -1 on both sides. you get -7/5. We usually like to leave it as a fraction, okay? Fraction is the preferred way. But if you like to write in the whole integer form, which the question didn't ask for, but you can, you get 5y equals 2x minus 7, and multiply everything by 5. You've learned the skill before in the previous chapter. Minus 2x plus 5y plus 7 equals 0. Okay, so both are equally fine. Right, so just quick recap. So how to find a perpendicular bisector again? Perpendicular bisector means still a straight line. Straight line is a gradient and a point. The gradient is that we need to find the equation of line AB, the gradient of AB, and then do negative reciprocal because it's a perpendicular line to AB. The point is not the point A nor B. The point is the midpoint of AB because that's what perpendicular bisector means. Once we know these two definitions there, what we need is just the execution part. And then, okay, right. If you're happy with this, pause the video, have a go at this question, okay, by the perpendicular bisector of AB. When you're ready for the answer, you can press play. So here's the final answer, y equals 2x plus 3. So first of all, I did my little draft, to tell myself what I need to work out. I need to work out two things, the gradient of L and the point, the midpoint. So to work out gradient of L, I need the gradient of AB. So MAB equals -1/2, do a negative reciprocal, the midpoint, 1/5, then you use the formula y minus y1 equals mx minus x1. So that's I color coded it for you so you can see where the numbers come from. And then, yeah, just do some algebra. And here you go, the answer. Voila. Right? Next one more. Okay. Pause the video. It looks like slightly a bit more difficult, but I know you can do this. Pause the video. Have a go at the question. Okay, see if you're able to work it out. When you're ready for the answer, you can press play. Right, here are the answers. Okay, so A is 1 and 2, B is 4√2, and we'll see if you can do it, you get 8. If you got the answer, good job, well done. You've actually tackled the hardest question in this 6.1, 6.2. But if not, let's have a look into why. The line segment ST is the diameter of a circle. So maybe I'll draw a circle just to help me visualize what's going on. Okay. -3, 6, -3, 6, and 5, -2. So maybe it's here, -3, 6, and 5, -2. Now, you'll be asking, so how do you know S is on the left and T is on the right without the coordinate axes? What I like to do is I just compare the Y coordinates. 6 and -2, that means one must be higher. S must be in the higher position than T. So, and -3 compared to X coordinate, -3 means S is on the left side and T is on the right side. And it has to be a diameter, therefore it has to be like this way, okay? Just like okay, they are opposite each other. So what I do then is, because that diameter means if I draw a straight line, okay, that means that's diameter, that's a center of circle. So that's the center. Let's use C to represent this, okay? So part A, basically, the C is the midpoint of ST. So I can work out -3 plus 5 over 2, 6 plus -2 over 2. You get 1 and 2, okay, as needed. Right, part B, find the radius of a circle in the form of n√2. To find the radius, now we know 1, that's 1, 2 now. Radius is here. That's the radius. To find the radius, it means you want to find the length. So radius is the length. So the length of, you can either do ST or, not ST, sorry, SC or CT, it doesn't matter, okay? Both of them are radii. So to use the math symbol for length, we use the 2 bars, remember? Okay, that means length. So if you remember the distance formula, I'll just rewrite again. Y2 minus y1 squared plus x2 minus x1 squared. Oh, by the way, or what you can do is, or you can do the radius, or you can also do the radius equals half of ST, by the way. If we know ST's diameter, we can also do half of ST, which actually in hindsight, this is a safer option than SC or CT, because if you want to use C in here, that means you have to rely on your previous answer, which is a risk itself if you got part A wrong. Therefore, finding the half of CT might be the safer bet. Anyway, so since I've started with SC, I'll go with it. Okay, so equals square root. So S is minus 3, 6. And let me write the coordinates on the side in here so I don't forget. So minus 3, 6, and C is 1, 2, right? Okay, so y2 minus y1 squared. Doesn't matter which way goes first, because when you square it, it doesn't matter. Think about this. 6 minus 2 squared is the same as 2 minus 6 squared, because they both get 4 squared, which is 16, minus 4 squared, which is 16. Therefore, anyway, it doesn't matter which way goes first. So 6 minus 2 squared plus minus 3 minus 1 squared. Put in the calculator, I believe you should get your answer for root 2. 4 squared, 16, 16 plus 16, 16 plus 16 is 32, so root 32 is 4 root 2. That's a radius. Okay, right. So that's part B. Part C, slightly more difficult one. The perpendicular bisector of ST meets the circle at points A and B. So draw a diagram. We've already done this. So let's draw a perpendicular bisector in. Okay, perpendicular bisector of AB. Perpendicular bisector means it must cross the center. Sorry, the midpoint of ST. It means the center, and it must be perpendicular. So it'll be like this way. So this is the perpendicular bisector. Okay, so this is the perpendicular bisector, and the points A and B are, let's say, here and here. Okay, and they want you to show that SA, which is the length SA, so SA, so S to A, and A to T, T to B, and B to S equals 8. Now, obviously, my circle is really ugly and really not on scale and really not a circle. But if you draw it properly, you might see a square. Okay, so what you want to do in here is essentially, what we want to do is we want to find AT. We know we want to find A and T. So what we can do is we can set up A, M, and T. So we know these are right angles, right? Because they are perpendicular bisector. So we know these are radii. So AC are all radius. So these are all radius. And this is a right angle. Okay. So what we want to do is, now we already know they're all radius here. So what we want to find out is essentially the AT. So part C. Well, actually, let me do it on here. Let me do it on here. So it might be easier. Part C. If I take this triangle, A, get a point A, and the point T, and the point C, we know these are radii, which is 4 root 2. That's a 4 root 2. That's a radii. So we find AT. So using Pythagoras, AT squared equals 4 root 2 squared plus 4 root 2 squared. So therefore, the distance of AT will be square root of 4 root 2 squared plus 4 root 2 whole thing squared. Put in a calculator, you should get 8. Okay, and because essentially these 4 triangles are congruent, they are equal each other. They are congruent because RHS, they're congruent. So therefore, okay, so therefore SA equals to AT equals TB equals BS. Yes, BS equals 8 because they're just congruent triangles. So you work out they're all 8. Okay, right. So just a small question for you to let you peek into a bit more geometric problems, which we're going to solve more later. That's the end of chapter 6.1.